Today we are going to see about the fault analysis that is coming under the unit number 4. Already you have studied, you have basic idea about the fault analysis, even though I'm just going to refresh. So what is fault analysis? So just introduction to the fault analysis. So fault analysis is the important part of the past analysis. It is one of the important problem because without fault there is no no power system without fault. Okay, any power system you take, sometimes fault may occur, but our main motive is to occurrence, not to occur that fault. Okay, now we are just here like as a power system engineers, we are monitoring, we are having more protection equipments to avoid those. We need to avoid those fault. But even though the study of the fault analysis is very, very important so that you can analyze the system. See what kind of fault is happening to the system in that time. What happens to the system? See, in every substation, you take every substation. If you go every substation, they will also have this fault analysis readily available with their hands. Okay, with all calculation. So what is the incoming feeder? What is the supply? What is the outgoing feeder? What is the supply? If a line to ground fault happens, what is the what might be the current? What might be the voltage? What is the change in current? What is the change in voltage? Everything. Okay, what is the real power? What is the reactive power? Everything they will calculate. And even line to line fault happens. What is the changes happening? And double line to ground fault, what is the changes happening? Like that, any types of faults, they will be having these kind of analysis readily available with their hand, so that if the fault happens in the particular system, so they can easily know, okay, this kind of fault happens system, so the system is the voltage is changing like this. So, okay, somehow in the distribution network we'll having this kind of fault like that, they may analyze. So fault analysis is one of the important problems in this power system. Short circuit studies, and also in that fault analysis we are going for short circuit studies or perform. Okay, so what they will do is, say, for example, their distribution network is for some 5 kilometers or 10 kilometers. Within that, they induce some fault. Okay, some short circuit happened in the system. Then they will analyze the bus voltage current in the lines and during the various types of fault. And also they will analyze all the things, as I said, voltage, current, power, reactive power, everything they will analyze. How say for example, they can go for the simulation. First they will go for the simulation, and even hand calculation also they will do, so that it will be accurate. So they will go for simulation like in second, say for example, that line is 10 kilometers long. In 2 kilometers there is some fault happening. So what might be the change in the voltage? What might be the change in the current? Like that they may analyze. So this faults can be classified as follows. The first one is symmetrical faults or balanced faults. Okay, symmetrical faults or balanced fault. This symmetrical faults will occur in the like a series in a single line. Say for example, three lines. Okay, R, Y, B, three lines are there. Only one line, this kind of faults are happening. It will not falls to the ground. Okay, that say for example, one there is a break in one wire, but it is not falling to the ground. But simply there will be some break in the wire, and it will just hang on the that line itself. Okay, so that is called the symmetrical faults or balance fault in the line. That is, it is also called series fault. So unsymmetrical fault, line to ground fault. That is, one line is falling to the ground, and line to line line to line fault. So line to line fault is like R phase is falling on the Y phase, or Y phase is falling on the blue phase, like that. Line to line fault. Next, the double line to ground fault. Double line to ground fault. Double line. Okay. that is falling to the ground. This kind of double line to ground fault, when our some severe rain, okay, it is severely raining outside. That particular time, some trees may fall. Okay, so trees branches may fall. In that first line may touch the second line, and that two lines may goes to the ground. Like that also it may happen, and line to line fault also due to some heavy winds, like that, and also there is no weights. There is no weights, even weights given to that particular okay string. Okay, then automatically that line can do that some wagging dance. Okay, you can see some YouTube videos how the lines can doing the wagging dance. Like in some other northern countries, like cold countries, so there will be some ice breeze will be there. Okay, it is not normal breeze like that happening in the hot countries, like icy breeze. So there the wind velocity also will be very more. So the line will be swinging like anything, like will do swinging. No, like that the line will go swinging. Line will goes and come like 10 meters also. 5 to 10 meters also, it will go and come back. So like that, in that particular time, what happens is due to the weight happens in the on one line. So one line will falls to the other line. Okay. So due to ice formation on the one line, so that line will falls to, so that is called line to line line fault. So line to ground fault, light to ground fault. And if you comes to triple line fault, like some snakes may climb. So nowadays it is not happening. And the kites, some kites may fall. Kites also, say for example, it made of plastic and all. It is also insulated only. Sometimes if it is raining heavily, okay, and sometimes some like in the poles itself, you may see some plants. Okay, some plants, it is some shrubs. It may go up to the line, and it will touch that green color shrubs, green color. So that will easily conduct. Okay, so that may happen. Like it may goes to three lines. So triple line form. So that may also happen under some snakes and some birds. Some monkeys like that, they may conduct all the lines. Okay, they may just sometimes we may see some monkeys were playing on the lines. Okay, on the lines. So sometimes if faultly, if the one monkey is hanging, one hand is hanging in the one line and another hand on another line, so this also will conduct. So like a double line form. Okay, two lines will conduct easily. So there some fault might happen. Okay, automatically it will be tripping. Okay, so wherever the protection device for that particular in a distribution transformer or in substation, so it depends on where it is happening. So that kind of thing also will be happening. When the network is symmetrical faulted, the phase current and phase voltage possess the three-phase symmetry. That is equal magnitude and equal phase shift. So that might be the equal phase shift will be there. So if this varies, say for example, this any fault happens, automatically this phase shift also varies. Phase shift also varies. So that we can easily analyze, okay, there is some fault has happening in the line. And sometimes current will be more in one phase alone. Another line, it will be having less current. So that time also they can easily analyze. Substation, they will monitor minute by minute, maybe 2 minutes once or 5 minutes once. They will monitor all the current happening in the particular feed. So anything one feeder, one line may goes to very high like current, and one line very light current will come. Okay, so then sometimes in our home also, you will feel this fault. like phase also you will be have sorry, in neutral also you will be having some slightly, if you keep the tester in the neutral. Okay, so in like plug points, you can see sometimes your only few loads only will be working in our home. Okay, so if you test with your tester, so two in phase also like light will come, and in neutral also you will feel the light. So in neutral also you'll get the phase. So two phases will be coming in the single phase line. Okay, some like some motors like that it will easily pick up. Some like TVs and all will not pick up, because TVs again there is a small rectifier unit is there in TVs and computers and all. So that will not pick up. Some loads, some equipments will pick up. So this kind of things you may feel sometimes rarely. What they will do in the pole if you see that if it is single phase line, so phase will wire will be there, neutral wire will be there. So the neutral wire will be touching your some phase wire. So you'll get the two like phase and neutral. You'll get two phases. Okay, so there the lineman will change that he will climb to that particular pole, and he will change that phase to neutral, neutral. So you'll now you'll so every load like every equipment, there is no of any equipment. So like that also will be happening. So these also coming under the fault zone. Sometimes due to heavy wind, okay, heavy breeze. So in this kind of this neutral wire also will be touching the face. So that time we need to call to that your electricity board people. They have to come and do all the things. Okay, so this might be happen some very few times. And this symmetrical fault is more severe fault. Symmetrical fault is a more severe fault and most amenable to calculate. Okay, it is not easy to calculate this symmetrical fault. Okay, then if you see the current flowing immediately after fault consists of a AC component which eventually reaches the steady state, and a fast decaying DC component which decays to zero. So this also might be happening. For analysis, only the AC component is considered here. So what happens is the current flowing immediately after the fault consisting of AC component, which eventually reaches the steady state, and fast DC component also which decays to zero. So okay, so here if you take this fault current IF is equal to E Thevenin divided by Z Thevenin plus fault impedance. Okay, that is ZF is nothing but fault impedance. So where TH is nothing but Thevenin impedance, or Z Thevenin or Thevenin impedance. Okay, so here E Thevenin is nothing but Thevenin voltage or pre-fault voltage. Okay, pre-fault voltage is the voltage before. Okay. The magnitude of a fault current depends on the internal Thevenin impedance of the generator plus the fault impedance. The internal impedance of the generator under short circuit condition is not constant. So in fault analysis, while doing problem, you may get all these things. Okay, the magnitude of fault current depends on the Thevenin impedance of the generator plus the fault impedance, and the internal impedance of generator under the short circuit condition is not constant. That and all, while solving the problem, we can see clearly. For a three-phase short circuit occurs on the unloaded generator, behavior can be divided into three periods. Say, for example, like a steady state period, transient period, and sub-transient period. You can see so how say, for example, it is what is phase, single phase. So how the magnitude is changing, how the magnitude is changing. So it is changing from it is going high and coming down. Okay, so this is called a steady state period, transient period, and sub-transient period. and this the actual magnitude is this. So extrapolation of steady state envelope and the extrapolation of your transient envelope, like that it is happening. The magnitude getting changing. So in this axis, we are taking the symmetrical shortcut current. Okay, symmetrical shortcut current. So here you can feel this all the how it is changing your waveforms, how it is changing, how it is changing, how the transients period will be, how the subtransient period will be, like that you can see. Next step. So what is subtransient period? The period is lasting only for few seconds. Subtransient period, only for few seconds. Say for example, if a sudden say due to some faults, that fault might be of even 1 minute. Say for example, sudden breeze is happening, sudden some heavy wind flow is happening in particular area. So that one line can touch another line just for a few milliseconds or few microseconds. Like just it will touch and come. Okay, in that time you may feel this kind of sub transient period. This period is lasting for only few seconds. In a substation, you can note down this clearly. Okay, so suddenly the current is going high and coming back in immediate time. Not more than 1 minute also. It is like as I said, it is in milliseconds. It's going and coming. That's all. That is few cycles only. It will be changed. What is this transient period? Now, after subtransient period, transient period covers some long time. Say for example, so that transient period may go. Say for example, sudden lightning is happening. Sudden lightning is happening. So after this subtransient period, so this may come. The lightning may occur for some times. Okay, it is also some microsecond, but that microsecond also will matters. It will be for it will be lasted for some period. Okay, so after that's what they said. After subtransient period, transient period covers some long time. Some long time. Next is steady state period. After transit period, system is in steady state finite. After that, it will come to the normal state. Normal state in the sense, say for example, it is 440 volts or some 220 kilovolts or 110 kilovolts. Like that, and suddenly it is coming to the that normal position, normal period. So that is called your steady state period. Next, short circuit studies are used for. So what are the uses of short circuit studies? This is one of the important 2-mark question. Short circuit studies uses. Short circuit studies are used for proper relay setting and coordination. So how long? So PSM, okay, plug setting multiplier. So that and all you are setting, no? So if you analyze the short circuit studies, so you can easily go for the relay settings. How long you need to go, how many microseconds or how many nanoseconds you need to give for that particular relay setting, so that the relay will okay sends the signal to the circuit breaker. Like that, the settings might be there, and also coordination. Okay, next to obtain the rating of the protective switchgears. As I said, after relay settings, you can go for the rating of the switchgears. So how long it will happen? So what is the amount of current going to which current? If you analyze previously, okay, it is going to which level, so that what is the protective switchgears might be used in that place, particular place, like that you can analyze. Next, to select the circuit breakers. To select the app circuit breakers, whether you need to go for numerical circuit breakers or differential relay circuit breakers, like that differential relays, like that what circuit breaker is apt for that particular types of parts. So that you can easily analyze by using this short circuit studies, and to perform whenever system expansion is planned. So say for example, now you any power system engineer, as a power system engineer, you need to plan for like long term. So if you just plan for this much kVA load for that particular, this much kilowatt of load, or this much megawatt, say for example 0.25 megawatt of load in a particular substation. So you need to plan that substation for zero point 0.5 megawatt or 1 megawatt load, because sometimes due to the industrial revolution, due to the ever increasing the load, like suddenly we need to raise the okay capacity of the substation. So that time one new transformer comes, one new feeder may be added. Okay, now one new area may be added. So you need to go for expansion. So and also as per the short circuit studies, if you perform the short circuit studies prior, so say for example there will be an increase in the like say for example 10 kilometers is the range for that particular substation. So you can go for further, because further you can because areas they will extend like anything. So some new area is coming on the 12th kilometer. So there also, so there suddenly some fault is happening. So what are the protective equipments to be installed there? So how many distribution transformers to be installed there? So everything will be analyzed once you do the short circuit studies. So so expansion also will be possible. Next, to select and set phase relays, while line to ground fault is used for earth relays. Yeah, three-phase fault information is used. So say for example, to select the and set this relays, and also line to ground fault is used for earth relays. Okay, earth, you need to install the earth relays for this line to ground fault, and the three-phase fault information also will be used for this all setting this relays and all. Next, coming to the solid fault or bolted fault. Sometimes they may ask in a 2-mark question, what is bolted fault? Okay, what is bolted fault? Write about the bolted fault. Like a fault represents the structural network change equivalent with that caused by the addition of the impedance at the fault of the place. If the fault impedance is zero, the fault impedance is zero, then the fault is called bolted or solid fault. I come again, I repeat once again. A fault represents the structural network change. Okay, so whenever fault happening is the suddenly that network will change. That network structure, equivalent circuit, everything will change for a few moments until the fault will be cleared. So which is equivalent with that caused by the addition of the impedance at the place of the faults. So that is with the caused by the addition of the impedance. So there some impedance might be added. Some impedance, some fault impedance might be added at that place of the fault. If the fault impedance is zero, okay, if that particular thing, if the fault is happening, if that fault impedance is zero, then the fault is called bolted fault or solid fault. Okay, so like that, the fault is happening, but the fault impedance is not changed. That is zero. That is what that is fault is happening, but it is not that is no any major changes happening in the system. Again, the fault impedance is zero. So that is called that is predefined fault. That is, say for example, sometimes in a substation you may feel, as I said, for some milliseconds, like one line is touches to other line. Okay, there it is going to change, but suddenly that line it is not touch as it is. It is touching and coming back. So if you analyze the fault impedance, that cycles might be changing. That like magnitude of the voltage might be changing for few period, but the fault impedance is zero. So that is called bolted fault. That is predefined fault. So we know, okay, this fault is happening, but there is no any changes. So that is called the bolted fault. This fault is called the bolted or solid fault. Okay, that is called solid fault. Next, need or importance of a short circuit study. Need or importance of a short circuit study. This is also one of the 2-mark question, or sometimes 4-mark question, or in subdivision they may ask. write short notes on importance of short circuit study and all. So the system must be protected against heavy flow of short circuit, heavy flow of short circuit currents by disconnecting the faulty section from the healthy section by means of the circuit breaker. So circuit breaker immediately will be tripping. To estimate the magnitude of the fault current for proper choice of the circuit breaker and protective relays and short circuit study is essential. So for studying that fault or to estimate the magnitude of the fault, this proper choice of we need to go for correct choice of circuit breaker and as well as the relays and essential short circuit study. Okay, you need to made prior. We need to uh, uh, simulate this short circuit that is happening in that particular line, that is line to ground fault, double line to ground fault. Then what might be happening to the that particular distribution transformer? From the distribution transformer, how the feeder will suffer. From the feeder, how the whole substation will suffer. Like that, we are analyzing everything prior. So that is important. Therefore, the short circuit study is more important in order to design or develop any protective schemes. So from that only you can design the protective schemes for the various power system. First, you need to make this short circuit study. Then after that only you need to choose your circuit breaker, relay, everything. So that is very, very important. Next, causes for short circuit fault or symmetrical fault. What are the main causes? Short circuit fault occurs in the power system due to the insulation failure. Sometimes insulation failure of the equipment or flashover in the lines initiated by the lightning stroke or accidental faulty operation. Sometimes the installation failure happens in a particular equipment. Say, for example, in a transformer, three insulators, three-phase transformer, three insulation might be there. Sometimes installation failure happens in the one particular insulator. So automatically there some fault might be happen. Okay, because it might be touching your that is one line to ground fault. That is that line is touching your transformer. The transformer is earthed. Okay, so line to ground fault. There transformer fault will be happening. So like due to insulation failure of any equipment. Okay, and say for example, sometimes in a substation this might be happening. Okay, in the feeder operation, some skilled workers will be there. Okay, some technical assistants will be there for operating this your feeders. They need to close the feeder. Sometimes they need to open the feeder. Sometimes it depends on the load and it depends on the how the system is operating. So in that particular time, what happens is sometimes they may forgot to wear the gloves. Simply like that, okay, straight away they will go to that feeder, they will touch the handle and they will sometimes, even though that is insulator, sometimes okay, many times nothing will happen. Sometimes in the hard cases, there might be some insulation failure, heavy shock you may feel. Okay, so I know few people who are working in the substation. They may lost their one hand also due to the not wearing the gloves, because sometimes many times it won't happen. Sometimes due to bad luck or sometimes not bad luck. We have to, because we are power system engineers. So it is only insulation failure. Insulation failure happens in the particular feeder like that pipe. Okay, that handle might be there. That handle is some insulation failure may happen. So sometimes if you directly you do with your hand, then you may feel heavy like a heavy shock. That is 33 kilovolt line is okay coming inside your body. Sometimes half of your body will not work. Half of your okay. So like one hand, one leg will not work. Sometimes some one half of the brain will not work. Like that many, because 33 kilovolt, 33 kilovolt, not 33 volt. 33 into 10 to the power of 3 volts is coming like to under to us. Okay, to us means you see the that fault. Sometimes loss of life also. So this kind of things. Next, equipment or flashover of the lights. So sometimes equipment will flash over. Sometimes what happens in distribution transformer? Okay, so we need to test the viscosity of the oil every time, like once in a while. Monthly once, 30 days once, you need to go for frequent check and we need to test the viscosity of the oil. So sometimes due to maintenance, they might not be check this like transformer oil viscosity at all. So sometimes what happens is this oil will get flash over. Sometimes due to heavy load, this transformer oil will like it will boil like anything. Okay, it will boil due to full load. Okay, transformer oil will boil like egg because you need to replace the transformer oil and you need to test the viscosity. If the viscosity is not there, then simply the transformer will boil. Like how we will heat, so how we'll heat the water. No, like that, the transformer oil also will be boiled and sometimes it will flash over. Okay, that oil will flash over, it will come out. Okay, and also it causing loss of life to whoever standing near to distribution transformer. In some villages, what they will do is they will take the cattle and they will they will simply put it in the distribution transformer, cattle, some goat or some cow like that. They will simply take that cattle and they will tie into the distribution transformer. Sometimes what happens, this kind of a flashover of transformer happens, that oil will come out and it will blow, like it will come out and fall on the like cattle or whoever standing nearby also. Yes, say for example, we are standing nearby to distribution transformer and we'll just chatting. That time we may get to the like it will be like that oil temperature will be like 500 degrees Celsius. Okay, 500 degrees Celsius. Okay, like it will be boiling like anything, like 200 degree, 300 degrees Celsius. That oil will boil. Okay, it will fall onto our body. Means what happens? So it will be a severe accident. Okay, sometimes you may lose life also. Okay, so this kind of thing and the flash over in the line. Flash over in the line, some two lines touches means so it will flash over like anything. Like say, don't try in your home. If like you just touch two phases, say for example, three phase line in your home means you take one phase and take one piece and two phases. If you touch, okay, you'll get severe flash over, severe flash. And even in single phase also, just open your switch box. Switch box. Okay. So two switches might be there. You take one wire. Okay. Two take one wire and you touch the again the phase. Okay. Two phases. If you touch and also if phase and neutral just you touch it. Okay. You'll get severe flash out. Imagine that is only 230 volts in our home. If same thing is happening in the lines, normal lines like a 110 kilovolt line or 220 kilovolt line or 440 kilovolt line or 1000 kilovolt line, this flashover will be like anything. Okay, it will be like a lightning, not even lightning, more than lightning also. So that kind of thing happened. And also sometimes lightning stroke for falling on one particular line, lightning stroke. That time you may see some videos in YouTube, lightning strokes falling on line. So what happens? So it's kind of flashover will be like anything. Okay, you can't see in your eye because it is like in nanoseconds or microseconds, no? So it may come and go. That's all. But that flashover will spoil everything. Like, okay, the lines will break. Okay, lines will break now. So we need to identify the line where the line is break. So from substation, they need to reach that particular place. A switching substation might be there. Say, for example, imagine 440 line, 440 kilovolt line. There, some line to ground fault has happened. Okay, some switching substation will be near. So switching substation range, they might be given some at 25 kilometers, 30 kilometers range. So they need to reach that particular area. It will be so your transmission lines, overhead transmission lines will not be in roadside. It will be in deep villages or okay in some restricted areas in forest. Imagine they need to reach that particular place. They need to reach that particular place. So, say for example, from that switching substation to that particular place, they may take it may take some half an hour or 1 hour also to reach that particular place. Sometimes if it in for forest, okay, some wildlife forest, there some fault is happening. So going there itself will take more time, and we need to DC. First, you need to DC that line. Okay, that is DC means you need to switch off the two feeders, this side and this side, because all are connected in ring main. Okay, one line, one side alone. If you off and one side, if you work again, this one. So sometimes line will be flowing. Okay, so you need to clear that fault. You need to clear that fault. So there are many techniques are there. We'll discuss that in separate class. So okay, so here you need to. So it is very okay. It is very complex thing too, because it will take 3 hours time, 4 hours time, sometimes half a day, sometimes whole 24 hours also. Some deep forest. Okay, you need to go there, and wild animals will be there. So you need to first of all you need to protect ourselves. Then you need to do that fault. Okay, and that too some it will be rain sometimes. That too in night time. If you by the time if you reach, it will be night. Okay, there then many things are there. So it is, and sometimes what they will do, and they will come with a helicopter, and we are there while climbing itself. They will do all this fault corrections also. That also possible. So these are the some of the complex things for our power system engineers to clear those fault. Clearing the fault is very tough job. And when the line has been made safe for the maintenance by clamping, as I said, the clamping all the three phases to it. So see, for example, one particular fault happens in one particular. So you need to clamp all the three phases to the earth. Then you need to work, and not one side, two sides you need to clamp to the earth. So any accident, we may lose our life. Okay, that's and when due to slow fault clearance also, and yet the fault spreads across the other two fields. It is okay when a line which has been made safe for maintenance by clamping all the three phase to earth is accidentally made alive, or when due to slow fault clearance, and earth fault spreads across two other phases. Okay, so this should then all the things are there for proper choice of circuit breakers and protective relays. We should estimate the fault current under short circuit, and some of the induced rotor currents decay more rapidly than others. This also might be happening. So there are many things are there due to short circuit in the synchronous generator. The flux per pole undergoes dynamic change with the associated transient in damper and field windings, and some of the induced rotor currents decay more rapidly than say, for example, short circuit happening in the synchronous generator. Then you see generator, whole generator will get damaged, like a per pole undergoes dynamic change with the associated with the transient in damper and the field windings. If windings, some damper windings and field windings, any damages to these windings, then see generator is more costly, no? So it is not like a normal 1 kVA generator what we are using in our home or shops. It is like a 100 megawatt generator or 1,000 megawatt generator, 500 megawatt. It is very costly. This kind of short circuit happening near to generators. Okay, then the generator, old generator might be damaged, and replacing will take. We need to invest more money also, and takes more time. First of all, time also matters, because we need that synchronous chain, even though backup generator will be there. But even though, why to make fault? So we need to go for protective relays and all. The circuit model of machine change subtransient, transient, and steady state periods, as we seen in the figure above. Machine parameter that influence rapidly decaying components called subtransient parameters, while those influencing the slow decaying components called transient parameters, and those influencing the sustained components are called synchronous parameters. So these things will happen. Then the reactants in first few cycles from low subtransient reactants to higher transient reactants, and still higher steady state reactants finally. Next is the suitable reactance value for a circuit model of a synchronous generator for short circuit analysis depends on arc interruption time of the circuit breaker. This is also one of the important factor. Next, the determination of initial current flows on the occurrence of short circuit and the current in transient that flows at the time of circuit interference is used for selection of the circuit breaker. So we need to determine initial current flows on the occurrence of short circuit and the current in the transient that flow at the time of circuit interruption. Will be used for selection of the circuit breaker, as we seen before, and both generator and motor subtransient reactants are used to determine the momentary current flowing on the occurrence of a short circuit to decide the interrupting capacity of the circuit breaker, except when open instantaneously. Okay, so interruption capacity of the circuit breaker, so suddenly if it opens, so that also matters, and also subtransient reactance is used for generators, and the transient reactance used for synchronous motor. So what it is for? To decide the interrupting capacity of the circuit breakers. So except a bit open instantaneous. So we need to calculate this subtransient reactance for generators and transient reactance for synchronous motor. So these are the some of the important points for this importance of the short circuit study. So they may ask simply need for short circuit study in a 2-mark question, or importance for short circuit study as a 2-mark question, or sometimes short notes like half of your long answers. They may ask one part of long answer. They may ask 5-mark questions, or like that.